All right, Algebra 2. So in today's lesson, we're going to be given a log argument, and your goal is to expand it completely using the big three log expansion rules. Recall that if you have multiplication inside of a logarithm, it can be expanded as the sum of its respective logs. And the argument can be broken down into a sum. So log of a times b is equal to log of a plus log of b. Remember that the quotient difference rule states that if you have division inside of a logarithm, it can be broken down as a difference. It's just a subtraction problem with the log base. So log of a over b is equal to log of a minus log of b. And finally, the power factor rule. If you have an exponent inside of your logarithm, you can break it down by making the exponent fly to the front as a factor. So log of a to the x is equal to x log of a. Once again, it's only three rules. So let's get started with the first rule. Okay, so I've got log of 4w. Oh, by the way, before I forget, it applies to any base. Base 2, base 5, base 12, base 8, log base 10, log base n, log base e. Either way works. It's just I know that with the shelter in place, our resources are limited, so I'm going to keep it with common log and natural log for this unit. But if this was log base 2, you would spread it out with log base 2. Okay, so for instance, log of 4w, what's going on inside of the logarithm? 4w means it's a multiplication problem. So if it's a multiplication problem, I can break this up by expanding multiplication into an addition problem. So if the first factor is 4 and the second factor is w, I can break this up into log of 4 plus log of w. And if you want to go to college, they really like it when you cite your rule. So what rule did we use? We used the product sum rule. Okay, the reason why we went from here to there is because of the product sum rule, and I cannot expand this anymore. So multiplication on the inside means I expand it with addition. Moving on to problem number 2. The natural log of 9 over v. That should be a 9. I know it looks like a q, but for the sake of argument, let me just straighten that tail out a little bit. Okay, the natural log of 9 over v. Well, what's going on inside of the argument? Well, it's division. So if I have division inside of a logarithm, I can expand this by making it a subtraction problem where the numerator minus the denominator. The natural log of 9 minus the natural log of v. And that is done by the quotient difference rule. Cite your source. You're going to retain this in pre-calc next year. And that's how you do it. Okay, rule number 3, log of x to the 7th. What's going on inside of this? So I've got a base with an exponent in there. So what that does is that makes this exponent fly to the front. So this becomes 7 log of x, and the rule that we used was the power factor rule. Power fact, as a former student of mine called it. So by the power factor rule, log of x to the 7th makes the exponent fly to the front to make this 7 log of x. Do you guys see? Please email me if you're confused by this, okay? All right, let's do some more of these simple one-step problems, and we'll make them harder. Okay, so how about log of u over 13? What do I need to do here? Well, this is a division problem on the inside, so that becomes log of u minus log of 13 by the quotient difference rule. So by the quotient difference rule, division on the inside becomes subtraction expanded with their respective log bases. Okay, the natural log of y cubed. Well, I've got a base and I've got an exponent, so in a logarithm, the exponent flies to the front. Therefore, the natural log of y cubed becomes 3 natural log of y by the power factor rule. Okay. Let me go on to the next set of problems. I'll put them on a separate sheet of paper. All right. Now, see if you can do number 6 independently. Well, I've got the log of 8z. What does this look like? The log of 8z can be expanded because there's multiplication on the inside. Multiplication on the inside makes each factor become an addition problem with log of 8 plus log of z. And the reason why is because there's a product on the inside, so it becomes a sum expanded. So we used the product sum rule. We cite the source because it'll stay in our brain. There you go. Good stuff. Okay, now I don't want you to be afraid of this. What does ln of 6pt mean? Well, remember that 6pt is technically a multiplication problem. So even though the rule only applies to 2 at a time, let's use common sense. If there's multiplication inside, we can expand them with addition, no matter what. So that would be the natural log of 6 plus the natural log of p plus the natural log of t by the product sum rule. Okay. Now, this is where I need to combine steps, multiple steps at once. Okay, so I'm going to take a deep breath and look at this. What is the big picture of this problem? I've got log of x squared times m to the 5th. So remember, this is x squared times m to the 5th. So in the first step, I'm going to treat this like a multiplication problem. So now I've got log of x squared plus log of m to the 5th. Right? And the reason why I did this is because of the product sum rule. Is this fully expanded, though? I'm looking at you, log of x squared. You have log of x, but there's an exponent up on top. So that exponent can be expanded by bringing that to the front. And rightfully so, log of m to the 5th, that is an exponent inside of my logarithm. So both of these can move the exponent out to the front. So that becomes 2 log of x plus 5 log of m by the power factor rule. And that is how we completely expand log of x squared m to the 5th. Okay. Same thing with number 9. And eventually you could probably do this in one step. If you have a question, be like, I have an idea on how to do this in one step. You're probably right. Okay, but just remember that the power applies to, the 20th power only applies to A, and the 34th power applies to B. Okay, so the natural log of A to the 20th, B to the 34th. Okay. It's a multiplication problem on the inside. So if there's a product on the inside, it can be expanded as a sum with their separate logarithm, in this case log base e, or the natural log. So this becomes the natural log of a to the 20th plus the natural log of b to the 34th. And the reason why I'm allowed to do that is because of the product sum rule. Is this fully expanded though? No. ln of a to the 20th and ln of b to the 34th both have exponents in there. So what I can do is bring those exponents out to the front of the logarithms. So that becomes 20 natural log of a plus 34 natural log of b. And that was from the POW fact rule. See how quick these are? Not too bad. Okay, moving on to number 10. Log of k to the 4th over m to the 3rd. What is the big picture here? Well, this is a division problem. So if it's a division problem on the inside, it becomes a subtraction problem with their separate log bases. So log base 10, which means that this is log of k to the 4th minus log of m cubed. And the reason why we did this is because of the quotient difference rule. Okay. Is this fully expanded though? Well, k to the 4th inside of a logarithm means that I can bring that to the front. M to the 3rd, that's an exponent inside of the logarithm, I can bring that out to the front. And you'll notice this becomes 4 log of k minus 3 log of m. And that is from the POW fact rule. Power factor rule. The power becomes a factor in the front. All right, number 11. See if you can do this one on your own. The natural log of t to the 39th over q to the 127th. So that is a division problem, which means I can expand this by making it a subtraction problem. So that becomes the natural log of t to the 39th minus the natural log of q to the 127th. And the reason I can do that is because of the quotient difference rule. Division inside of a logarithm can become subtraction with the log base. And now I can make this fully expanded because an exponent inside of a logarithm brings that out to the front. So now this becomes 39 natural log of t minus 127 natural log of q, fully expanded. The reason why is because of the power factor rule, POW fact. Okay, number 12. So this one's a little bit different. Well, not just because I forgot to close the parentheses on this problem, but so what do you notice about this problem that's different from the first 11? Okay, so I like to take a deep breath and go, okay, so I've got a division problem, but specifically I've got two factors up on top, and the bottom is just x to the 8th. Okay, well, I could approach this in two ways. Either I could make this log of y to the 25th, z to the 24th, minus log of x to the 8th. You know what? I've got a trick up my sleeve. I'm going to tell you a little secret. You guys ready? Anything that's in the numerator becomes positive. Anything in the denominator becomes negative. So even though I'm telling you, okay, take step by step. Let's just use common sense. I'm going to make this log of y to the 25th, z to the 4th, minus log of x to the 8th. And then I'm going to tell you to product factor y to the 25th, z to the 4th. So let's just do this in an easy step. Okay, so I'm actually, you know what? I am going to show it in both ways. So the book wants to show it like this. Log of y to the 25th, z to the 4th, minus log of x to the 8th, and then you can break this up. Well, the reason why we did this is because of the quotient difference rule. And I can break this up, log of y to the 25th plus log of z to the 4th. And then don't forget about the minus log of x to the 8th over there. Remember, I could do this part because of the product sum rule. But you know what? I can bring out the factors now. I've got 25 log of y plus 4 log of z minus 8 log of x by the power factor rule, and the ink just smeared on prod sum there. So that is power factor. Sorry about the lighting, but yeah, I've got, so let me show you a little trick. Tops are positive, bottoms are negative. So I'm going to box this part. Okay, because otherwise I have to use a variety of colors and it gets really confusing. Tops are positive, bottoms are negative. Okay? So in particular, let's make problem number 13 a lot easier. So I'm going to show this with the easier way. Natural log of a to the 16th, b to the 24th over c to the 18th. I could do log ln of a to the 16th, b to the 24th over c to the 18th, but you know what? Tops are positive, bottoms are negative. Ln a to the 16th plus ln b to the 24th minus ln of c to the 18th. Tops are positive, bottoms are negative. Numerators are positive, denominators are negative. And now all the exponents are going to get factored out to the front. So the final answer becomes 16 natural log of a plus 24 natural log of b minus 18 natural log of c. Notice I didn't say any sources because I know the rules like the back of my hand. Oh, there it is. So I've got I combined the product sum and the quotient difference in here, but we all know that I did power factor on the second step. And the reason why I bring that up is because log of j to the 11th over n cubed p to the 18th, I could do log of j to the 11th minus log of n to the 3rd p to the 18th, but you would have to distribute the negative when you do product sum. So I'm going to tell you tops are positive, bottoms are negative. So that's just the quotient difference rule, basically. So log of j to the 11th minus log of n to the 3rd, because it's on the bottom, minus log of p to the 18th. Tops are positive, bottoms are negative. Now, log of j to the 11th becomes 11 log of j. Negative log of n to the 3rd becomes minus 3 log of n. And minus log of p to the 18th becomes minus 18 log of p. Box. And I think that's it. Yeah, that's it. But the main idea is that if there's a numerator, it's positive. If it's a denominator, it's negative. In the next video, we're going to be taking the expanded form and putting it into one neat little logarithm. That's called condensing a logarithm. Have a good day, guys.